All right, welcome everyone to another edition of the Subseasonal Forecast Contest. Today is June 16th, and we're delighted. We have a really special guest here today in terms of, one of the folks who's been doing subseasonal forecasting before it was even subseasonal forecasting or medium range forecasting. We've got Joe Bastardi here, who has decades of experience in medium range forecasting. So this is really a great honor for our forecast contest. And Joe, let me turn it over to you here. We'd love for you to give a little bit of background introduction in terms of your professional history. Also, any thoughts you have for where things are going. And then we're going to spend the rest of the time, of course, going through the forecast. And we'd love to hear your thoughts in terms of all the tips and tricks in terms of making a subseasonal forecast. So over to you, Joe.
Okay, well, thank you very much. I've wanted to be a meteorologist since my first memory. There are two things I wanted to be when I was a kid. A meteorologist, well, actually three. I wanted to be president of the United States too, but that didn't work out. But I did win student council president in 8th grade though. I wanted to be a meteorologist. I wanted to be a weatherman, all right, from my first memory. I also wanted to be Superman. The fact of the matter is that my mother made me a cape and I almost jumped out a second floor window when I was 3 years old. Because I thought I could fly. As far as the weather goes, my parents had to keep an eye on me because when I got outside, I'd lie on my back and stare at the sun with cumulus clouds going in the way to try to see the outline of the sun. And after a while, that can burn your retinas out. So that's how freaked out I was about the weather. My father's a meteorologist. He was the oldest freshman on the Texas A&M campus in 1961. And we all went down there, and that's why I bleed maroon and white. I wrestled for Penn State, but when it comes to football, it's really hard for me to, when the Aggies and Penn State play, it's like I'm divided against myself. But so I grew up down there, and my dad has a degree in meteorology from A&M in '65. So he comes from the old school, and he instilled a lot of that in me. My father taught me when I was a kid, the foundation you stand on today was built yesterday to reach for tomorrow. So he stressed knowing and understanding what has happened before. And I've always been a big student of history. I love all history. And so what happens is I started really digging into the weather, especially when I got into college, because my dad would tell me these, and I'm yeah, sure, like you're walking uphill both ways in snowstorms, to school or something, right? But then I went and looked, and I was a holy smoke. So I became sort of addicted to analoging before analoging became popular, okay? And I'm not talking about modeling analogs. I'm talking about go in and look at what actually happened January 1977, or go in and look at what set up Hurricane Hazel and how that could telegraph Hurricane Sandy, which is what my company did from October 21st. Now, the risk involved in this, of course, is that you get carried away with your own ideas so much that you try to close your mind to other things. You can't do that. What you have to do is understand, and this is how I operate now, sort of opposite to when Dave and I were working together. I always was sort of cocky and all this. I'm the dumbest man in the room. I look at it that way. But I want to win. So what happens is, I am going to look at everything that I possibly can, and especially things that counter my ideas, because two things happen when you look at things that can counter your ideas. One, they may be right. So what happens is you have to adopt that position. You become stronger anyway. Two, if you're convinced you're right, then your position is stronger anyway in the first place. Okay. So the second place, I should say. So I look at things very, very differently. A lot of you know me because of, the whole climate change things. I study much more what people on the other side are saying than what I already know. How much more can I add to what I already believe, right? So you got to go look at other things. Weather is a microcosm of that. And what is becoming crucially important to all of us now, okay, is that that with the warming that is taking place, and the fact that it's sort of disproportionate, all right, it's leading, I don't think, to more extreme weather, because I'll tell you what, if you went and looked at what happened, I often sit there and go, oh, why can't we see that happen again? You know? And then if something like it does happen, I hear, oh, this is the worst ever, right? I mean, you take a look at the 1950s on the eastern seaboard with those hurricanes. Looked at that monument there that said that the 5-minute wind speed 121 gusts to 186, a 1938 hurricane. I couldn't believe that happened. I go to Providence. My parents live up in Rhode Island, and I go to Providence. And if you go downtown, look at where the water was in 38 and 54. You can't believe that can happen, right? So I'm looking at things, and I'm looking back at those times. But what we have now is, because of the warming, the atmosphere becomes more sensitive, right? So, for instance, I'm a Madden-Julian oscillation freak now, all right? I really dig into that. I think that the MJO is becoming more amplified due to warming. Now, that stands to reason, right? If the water's warm, there's going to be more upward motion in the places that it's warmest. You take this winter, what happened this winter, right? ENSO 4 warmed up like crazy, and that was like a magnet for 5 and 6, phase 5 and 6 of the MJO, which a kiss of death for winter across much of the United States, right? And the computer models, and what sucked me in this winter was I've just bought the blend of the models with the European, all having the ring and showing it cooler to the east, and figured the MJO would be more toward, the colder phases, and see there's a huge bust, all right? But when that gains amplitude, you see the shift in the weather patterns. The models won't see it until it's actually starting to occur. Now, look at this cold air mass that got into the southeast over here. The big key with this summer, in my opinion, is, and we've got it warmer than normal, we believe it's warmer than normal across much of the country, is that there's probably going to be interruption of these, the real, hot weather patterns, right? For instance, you see what's going on in the Carolinas right now. I mean, Raleigh was 22 below normal for their max yesterday. That trough was not seen 3, 4, 5 weeks away by the European. I look at those European weeklies. And what's happened, folks, in my opinion, is there's so much warmth in the northern latitudes that gets washed out. It washes out. Now, if you wash it all out, and let's say you get to a situation where you're 15 days out and the model's trying to figure out where something is, it's very, very weak on figuring out what happens when it's warm to the north and cold to the south, or cooler to the south relative to averages. So it's just broad brushes the entire picture. So, for instance, in the European weeklies last night, we're telling our clients, hey, we're in a strong phase 2 of the Madden-Julian oscillation. Look out week 2. It's likely to get colder than what the model is across much of the central part of the United States and down into Texas. And the next trough split may be in Texas. Now, trough splits are very interesting. What happens is this. They are assigned that the subtropical ridge is actually a little bit stronger than normal. You might not see it, but it is. I'll tell you what happens with trough splits and why they're important for the hurricane season and why they're telegraphed. And we put out, and everybody had a similar. What happens with trough splits is the southeast side of that trough, the subsidence region of the jet, to the southeast of the trough. Now, in the wintertime, the troughs just try to overpower everything. But in the summertime, different story. So what happens is you get an amplification. A piece of the trough splits northeast, the other back southwest. What happens when you get an upper low that southwest through the subtropics and into the tropics, okay? What happens in front of it? There's divergence going on aloft. What happens if a tropical wave's coming along? Look out. That's why the position of the trough over North America and the Central Atlantic is so crucial during the hurricane season. And with the sea surface temperatures the way they are overall, it leads to the type of situation you're seeing No, we've already had 3 storms, all of them in our impact area. We have a pattern setting up day 10. That looks like what created Harvey in Texas. Now, it's early in the season, and I can't find a tropical wave that will come into the area of divergence and back of the. What we tell people in Texas is, at the very least, a heck of a lot of rain is coming. Where a piece goes across the north, another piece probably comes down back to the south and southwest. But instead of winding up over South Carolina, as you see now, it may wind up back over Texas, right? So that's a major market there. The 240-hour GFS ensemble is sort of showing that. You know, it sneaks. Hey, Dave knows me pretty well. You know, when hurricanes come along, I don't sleep. But these are the things that are going on. These are the things that are going on overall and supply a background. Now, when you go and analog this, right, you go back to previous years. Now, for instance, the rest of the summer, we have, so let's see, 2003, 2010, 2011, 12, and 17 analog for the rest of the summer. Why? Because the Madden-Julian oscillation in those years crawled in the month of June through phases 1 and 2. So it's a similar pattern. Once we get into the, there you are. Is this today's? Let's see. Go to the European. Where is that? I haven't seen it yet. See what the European.
That's the European.
It's bringing it back out in 2. Now, when you look at what 2 is a cool phase across much of the United States. So you don't sit there and go, well, I'm just going to forecast phase 2. What you do is you say, I'm going to make sure that my clientele knows that if the European is right, it won't be as warm, and it could be quite cool getting into phase 2. If you've noticed what's happened, and this is so beautiful the way the weather works. I mean, I'm just awed by the majesty of it all. That cooling of the water, and ENSO 4, all right, the MJO would go into phases 4, 5, and 6 and crawl through there during the winter. Look at this. Thanks, Dave, for putting that chart up. Look at how fast it ran through 5 and 6 and 7, right? Boy, it takes 6 days to get through 3 phases. And look what's happened now. If this could happen during the winter, you know, we could 50 inches of snow in New York City. It's crawling. It's crawling because of the response of the sea surface temperatures. So it's not moving nearly as fast through there. If that pattern persists through the summer, that's a very active hurricane pattern. All right, you go back and read Vitart's from ECMWF on the phase correlations to hurricanes. It's amazing how close all that is. So there are all sorts of signals being given off. I brought up the past, all right? We're looking at the models. We're also looking at the present that is going on. And the present situation, and the big key is the Madden-Julian oscillation. This is interesting. You see that when you look at, if you go to outgoing long wave radiation, I don't know if Dave can stick that up there, which has become one of my favorite charts. What happens is that we have seen, instead of strong upward motion just west of the date line, it's flipped completely. That we've been seeing a lot of sinking air going on to the west of the date line.
Hello, Jeff.
So it's sort of the golden age of forecasting now, folks, because what happens is you have you have things that you can look at that they're not going to give you the answer. They're going to question you so you can pursue the answer. So you try to set your clients up, all right? The other thing you got to look at is this, you know, with all the different models and the initialization schemes, it's kind of crazy with what verifies. I mean, I don't know if you guys look at this. All right. You look at the CDAS versus PRISM. I think PRISM is a gold standard of U.S. temperatures. I mean, the CDAS is 1 to 3 degrees cooler with its verification across Texas this month, for instance. And you see, if you have the GFS or the US model CFSV2, if you've been watching the CFSV2, it may have one of the worst forecasts it's ever. It's forecasted widespread cooler to actually going to happen. Is that most of the country will be above normal. Anyway, I don't know if I covered this correctly or what, but I'm done for a while. If I could have wrestled the way I talk, I would have been a national champ.
That's a great introduction, Joe. And so it's fun. We typically start with attribution, and you were mentioning the CFS. Maybe we could just kind of make this a little bit more of a Q&A. Since I think, since I think that'd be great. What we've seen. So we have these verifications. So let me just walk you through it just a little bit so that it makes sense. But for example, we'll look at the cooling season verification, and we only have 4 forecasts. We verify 1 forecast a week every Tuesday, the 16 to 20. And positive in this performance column, positive means better than the 30-year, and negative means worse than the 30-year. And we've been doing this contest now for, I don't know, like a year and a half, 2 years. And it's, I know it won't surprise you, but the CFS, you'll notice the bottom of the list here is the CFS, the worst score. And it seems like we see this consistently, heating season, cooling season, where in a lot of cases, there's a significant bias. You see we have the bias in the second column. We have the forecast count in the third column. Directionally correct means, are you on the right side of the 30-year normal? So in other words, if it's warmer than the 30-year normal and you forecast it warmer than the 30-year normal, you get a point. You're right. And then performance consensus, we don't have to worry about that, but that's on the end there. Anyway, back to the CFS. Just a question for you. One of the questions we've asked constantly in our forecast discussion is, we know we have this input, we get it every week, every day, whatever. How should we use it? Should we even be using it? Like, does it provide helpful information? Because from a performance standpoint, it seems like these scores are so, in often cases, so much worse than the 30-year normal that, what should we do with the CFS? How do you use the CFS?
Well, even the European is not exactly setting the world on fire either. But,
no, it isn't. It isn't. No.
No. I think. Well, the European is going to take over the rest of the summer overall, I believe. I'll tell you why. And it has trouble. We're what we call it. We're coming out of the saddle season. All right, saddle season is like right. And that's when the European notoriously has its worst problems. All right, it just missed the cold completely that came for April and May. I mean, it was a top 5 back-to-back April, May. So it missed it completely. If you go back and look 2-3 weeks before that, and during the summer and during the winter, when the jet reaches sort of an equilibrium for 2-3 months, it continues to increase, but not as fast as it does in the fall, to actually early February, I believe it is. And then it starts to back off. During those transitional seasons, you have the intersection going on here of model physics versus a planet that is got a distortion of the warming pattern. We all can see that. You just go look at, it's boiling across the north, and you get down to the tropics, it's not nearly as warm and even cool in some places. So you have a distortion of the pattern, plus you have the change in feedback that occurs every 2 or 3 days simply because of the change of the seasons, right? And then you start trying to figure out, Bill Gray was awesome with this stuff. He showed model chaos, all right? And the thing that we have to remember, because what's going to happen here, I believe, over the next 20 years to 30 years is it's predominantly warm, all right? But we have to remember that the warmer than average temperature is simply the warmth outdueling the cold by whatever it is, 0.8 C or whatever. There's still cold to be had. So how can the model see the cold when all it wants to do, when you get 51 members going out, 6 weeks, all it wants to do is, let me just find some sense of normalcy here. Okay, just above over here, most of the planet above normal, no troughs nowhere, right? So when you look at the CFS, what it does is it's got, I think what's going on with the CFS and US products in general, GFS, in the plains is where it's dry, it has a cold bias, all right? I was watching Texas during the cool down, and the model was predicting highs in the middle 80s, low 80s or whatever, and it was getting to 90, 91 in Dallas. The humidity was 22%. But so I think it has a cool bias there. All right. Here's the tricky thing. If it's going to get cold, the model that sees cold is probably going to see it first. That's what you actually saw happen in the spring, in April and May. The CFS didn't do a bad job. In the longer term was showing more cold. It just seems like it's hanging on through the entire summer to a pattern that was unique to the spring, because we had the change in the sea surface temperatures in the Pacific, which were huge. It's huge. You know what? Going back to winter forecast, okay? What busted this year was this. We have relationships, okay? Like we're like the Dr. Phil of weather. We love relationships, okay? Where you have warm water in one place versus cooler water in another place, blah, 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 back and forth. And the key was that ENSO 3.4 was supposed to be, and was, warmer than 1.2, but it was also supposed to be warmer than ENSO 4 to the west, right? When the further west the water is warmer, the more you, in the winter season especially, you're going to attract that phase of the Madden-Julian oscillation that promotes warmth in the east. And when you think about a La Nina, why a lot of times we have ridges in the east during La Ninas, well, La Nina is colder in 3.4.1.2 than it is over in 4. So when you get a situation where you're near and west of the date line and you're getting constant thunderstorms going off, like we saw this winter, it's like pulling teeth to move the pattern. So we've come out of that. We're coming out of that. In the meantime, the season is transitioning, right? So the models can't figure out what the heck is going on. So what I do is I look at where there are hints of cool. Like if you look at, okay, it's the European summer forecast has the core of the warmth, has the core of the warmth, where the CFSV2 has the core of the cool. It's great. So what happens is I look at those things and then look at what I think the Madden-Julian oscillation is going to be doing during the season, and I try to come up with the ideas. Listen, the tropics drive the global weather. All right. I mean, I understand. This is drilled into me from my father, because he was a hurricane nut too. Still is. Probably rooting for something to hit Rhode Island this year. But the tropics drive the weather. This is simple because there's so much energy available. Okay. The to the tropics, right? So what happens is you get these convective bombs going off. For instance, we love using, when you see heavy convection going off in the Indian Ocean, Eastern Indian Ocean, you say, okay, here comes the ridge, right? 10 to 15 days down the road. Now, why would that be? Because it signals a Madden-Julian oscillation 3 into 4, 10 to 15 days down the road, it's liable to be in 6, it's the ridge, right? So a chance today, folks, to actually have signaling that we've got to study, we've got to line it up. I advise everybody to get on that Australian MJO site and look at the Madden-Julian oscillation. They have it all the way back to 1978. And then the problem is you have to try to adjust your head. Well, how is the atmosphere reacting now compared to it was when the oceans were anywhere from 1 to 2 C colder in general? Okay, so you have to try to think that. And of course, I don't know that modeling can keep up with this. All right, maybe it can, maybe it can't. But right now in the saddle seasons, those are your biggest errors. I bet you when we get done with the summer that the European does a lot better than what it is now, but the CFS may still be sitting there on the bottom. So anyway.
That's that's helpful.
I
So
hope.
yeah, so maybe let's shift gears a little bit to today's forecast, if you're okay with that, Joe. And
Cool.
I'm gonna, if you don't mind, but maybe we'll ask a couple of the
Yeah.
participants here, some of the student forecasters, to give their rationale on today's forecast, and you can play the role of angry client, or not angry. You don't have to be angry,
No.
but tough client. How about that? And feel free to jump in and grill them and ask some questions. And by the way, we actually think this is helpful. Like what we're trying to do as part of the contest is to simulate, kind of experiences that folks like our current student and recent grads are going to experience in the job market. So, they're going to have difficult conversations, right? They're going to have tough conversations with clients and other folks when their forecast isn't right, or explaining complex situations, or just getting tough questions and stuff like that. So I'm gonna ask a couple of the participants to jump in. And again, Joe, you're on the other side. You just feel free to interrupt. You just feel free. You're receiving the forecast. You wanna get, you're making decisions based on this forecast. So you just jump in,
Yeah,
ask questions, whatever.
let me say something. Let me say something about these guys. A lot of, especially hedge fund guys, it's like Dodge City back in the 1800s with their attitude. I'll never forget. I went to a what was it, 14-15 winter, I guess it was. Yeah, and it was everybody's forecast a warm winter. I said it was going to turn into a very cold winter, mid and late, right? And these guys were screaming at me. I mean, I was at a dinner, and it was like I thought they were all, it was like being on the set of Billions or something. I never had encountered stuff like that. We used to have arguments like crazy at AccuWeather because we were passionate about it back in the 80s and 90s. Everybody was constantly, I mean, it was a fun place for me to work, put it that way. But now I don't have a lot of angry clients. So, maybe they just don't yell at me as much as they used to yell.
Yeah,
So,
Joe, they still yell at me a lot. So maybe you're doing something better.
really?
I don't know. No.
Maybe I
But,
got the right people. I don't know. I'm just a happy guy, so whatever.
all right, so to set the stage here, I think everyone can see my screen, and if anyone would like to share the screen, including Joe, please let me know. But so for today's forecast, today, we're June 16th. This is the 16-20 forecast. So we're forecasting out for the first 5 days of July. We're forecasting cooling degree days, and thanks to our friends, Maxar has given us this data. So we're using national or population weighted cooling degree days as based on the Maxar CDD numbers. And just so everyone can kind of normalize themselves, the 30-year normal for this period is way down here. It's just about 50 CDDs. So 50 CDDs is the 30-year normal. The 10-year normal is 56.7. And in terms of the range of inputs for today's forecast, we've got the warmest or the hottest is industry number one, and that's Maxar. I don't think they mind us saying. So they're up there at 64.3. The coldest or least warm is the CFS, not surprisingly, at 49. And Joe, we also include a spread here. So, as a function of confidence. So the lower the number, presumably the higher the confidence, and vice versa. So with that, let's get a couple of our folks online. Who wants to kick us off?
I guess I could volunteer as tribute.
Or why don't you introduce yourself real quick?
All right, I'm Michael, Garen. So, you want me to give more than that, or?
No, that's fine. Michael's a recent graduate from Rutgers. All right, Michael, let's tell us about. Remember, Joe's your client here today. Go ahead.
All right, so my forecast is for 62 CDDs with a slightly higher confidence spread of 7.2. My formula is I use 50% teleconnections, so NAO, AO, PNA, EPO. and 40% of the CPC forecast, 3 to 4 week forecast. And I use the 10 year as a baseline starting point. So this week, teleconnections seem to be on the positive side of things, especially the PNA, a very positive signal from that. And then the NAO and AO and EPO are all around neutral to slightly positive, but they've been verifying on the positive side of their forecasts at range. So treated those as being positive as well. So overall, a warm signal from those. CPC, very warm, especially in the I-95 corridor. So New York, Boston, Philly, all predicted to be above average, over 60%. So pretty warm signal from them. So that's what got me to my value of 62. Any comments, complaints, questions, concerns?
Well, let me ask you a question. What is a 60%? What does that 60% chance of above normal temperatures actually mean?
I just take that to mean that there's a good chance that it'll be warm. So I don't necessarily know what it means to them,
Well,
but to me, I just take that as a warmer signal.
well, it's guidance, but Michael, is it 1 degree warmer, 4 degrees warmer, 6 degrees? If it's 6 above normal in Boston, then it's the equivalent of Richmond. If it's 1 above normal in Boston, well, it's like being at New Haven. So what does that? You're banking on a lot of very warm weather in the Northeast, which if we look, this is what the week 3-4 outlook. I don't have a big problem with that, but what I'm worried about is transients, that enough transients comes along, that the magnitude of the warmth. I mean, you may say, listen, I got a warm forecast. The magnitude of the warmth is something that's going to be quite tricky across you know, where it's warm all over the place like that. So I just always try to say, you know, I call the probabilities. This isn't a forecast. It's a scheme, okay? If you've ever taken, you guys know what Breyer scores are? Everybody, you square your error, right? So what happens is, when we took the probability forecast at, you know, when I was in forecasting school or with Joel Myers, okay? I was always, you know, I was the same way as when I played blackjack. Like I go, a 90% probability of above normal. And if it busted, I got killed, right? Because you square the error of 0.9, that's 0.81. And it never really told you what the temperature is going to be, okay? So that's something I try to bring up with folks that, that you know, it's kind of hard to believe that in week 3 and 4, there's absolutely nobody with any below normal temperatures, right? Across the entire United States. So I think you're good dwelling on New England like that. I just wanted to bring up that if it's me, if I were a client, say, well, how warm is it? Okay, you've got your cooling degree day forecasts like that. It's above. It looks like significantly above normal, but can it get warmer? You know, I still think in terms of temperatures a lot of times too, and then Tom Downs translates that to cooling degree days and heating degree days. But anyway, I think it's a good analysis. I will tell you this: teleconnections, you know, a strong PNA is important. I mean, take a look at the July correlation to a strong PNA. You can see what goes on, right? I don't know if Dave has that there. So, but the NAO and some of these other things that are going on. By the way, you notice how that PNA responded to the flip in the Mann-Julian oscillation tendency. As we got into April and May, we started seeing more and more positive PNA and more cooler air masses invaded the United States. So that's a pretty cool signal, okay, for especially the Southeast, all right? When I see stuff like that, if it were August, I'd be licking my chops for tropical activity. So, you know, and what you have to a little bit be concerned about is you look at the day 12 European, for instance, the trough in the northeastern part of the United States. Does the assumption by the European, I think it's right. I think it's right because the July analogs to the MJO are very warm July across the country. And they're warm in New England, but the center of the heat is back across the plains. That would indicate that you got a good idea in New England week 3 and 4. So I would advise you and all of you to start studying the MJO as far as these things respond to the Mann-Julian oscillation, folks. Okay, I'm going to give you another example. We'll go back to the winter. Big thunderstorms going off. Okay, like crazy. ENSO 6, right? Pumping all that heat in the air. Where does the ridge develop? It develops at the date line. It develops so far north and so strong, tightens the jet. Bingo, polar vortex, much stronger than normal. Bye-bye winter, right? So, and everything responds, right? The Arctic Oscillation has to respond. PNA has to respond. The NAO has to respond. So I would think that you gotta go in and add another teleconnective factor in there. I love your model blending. I love the idea of taking percentages like that, but I'd start getting a little bit more into the Mann-Julian oscillation because it's the capo di tutti, as we say in Italian, the boss of the world.
All right. All right. Well, thank you, Michael. Yes. Who would like to go next?
10.
All right. I think that's Philip. Philip's been,
Yes.
no pressure, Philip, but he's been one of our top performers since the start of the forecast contest. Go
Hey,
ahead.
meteorology, this is a high pressure job anyway.
Yes.
Thanks for
So-
laughing at that.
So just a quick background, I am a Rutgers graduate and I am currently in Stony as a PhD student and my forecast is here. So I mentioned in the chat first that I have links to the PNA and the NAO temperature correlation maps, which may or may not be helpful. And but I guess I'll just jump into my forecast. So I mentioned that we have the MJO signal in phase 3, with the model suggesting that the signal will stay in place or possibly retrograde into phases 1 and 2. And because of the uncertainty of the tropical signal, I was using one of the longer lag composites as my tropical forecast. And then putting everything together, my tropics was treated as a warm signal with 53.07 CDDs. The CPC, as was already mentioned, shows the warmth in the Northeast and the Pacific Northwest. And I mentioned that these aren't the greatest CDD producers, but with the general warmth, I treated the CPC as a warm signal. And as was already mentioned by Michael, we have the teleconnections with the positive PNA. And it looks like the EPO is also slightly on the positive side, although it's not as certain. And then NAO forecast is also near neutral, maybe slightly negative. So putting that together, I thought it looked a bit like a slightly warm signal. So I got 52.9 for the teleconnections. EC is showing anomalous ridging over the northern tier with basically no troughs on their North America map. And the EC is very warm compared to the CFS, which is actually very close to the 30-year normal for a change once. And putting everything together, I reached my final value of 37.5 CDDs with a normal spread of 5.9, which matches the 30-year spread.
I don't have any beef with that. I think the one thing that I'd be looking more closely at is a 5-year moving average, because we have sea surface temperatures over the past 5 years surrounding the United States that are quite warm. And the other interesting thing is it's not the daytime highs that are pulling all this, all right? It's the nighttime lows that are really doing the dirty work. And a lot of that is, there's some change. Oh, that sea surface temperature. It's got me watering at the mouth. That's the hurricane signal right there. Cool over warm like that. But the water has cooled. I'm going to use the word dramatically in the Gulf of Mexico and off the southeast coast of the United States. Remember during the winter, it was like, dropping an orange paint bomb out there. And that may tend to lead to across the southern tier, in the I-20 corridor down across Florida. I'm friends with Eric Blake, and he's always complaining about how hot it is in Florida. Maybe this year there's not going to be a lot of heat in Florida per se. You also have to start thinking about the hurricane seasons. Active hurricane seasons are interestingly erratic. You have a 2004 season where it's very cold, across the United States. There's actually an weak El Nino going on. And then you have, seasons like 2011, which was quite warm, 2012, 2010, all three of those were warm. But then you have 2017, which was quite cool in the center part of the United States. A big thing is figuring out where the ground is dry and figuring out where it's wet. If we see something come up into New England and just turn things around there because it's been drying out, it hasn't rained in Cranston, I believe, in my dad in 2 weeks. Okay, so if you see that turning around, that could blunt the temperatures there. But I like what you were saying overall.
All right. Thank you, Philip. I think we have time for at least one or two more, and then we could also see if anyone. I want to leave a few minutes just in case anyone has any general questions for Joe. And I also want to make sure we don't keep Joe more than an hour here.
Yeah, I'm down Lancaster. I'm down Lancaster right now.
You're in Lancaster?
Yeah,
PA?
I was meeting with some congressional people today about a very interesting topic, but get into that later, maybe.
Okay. Let's see. Anyone else on the line would like to go?
Yeah, I'll go next, Dave.
Okay. Go ahead, Zach.
Hi, Joe. My name's Zach. I'm a recent graduate from Rutgers, and I'll be starting up grad school at Stony Brook in the fall. So my forecast for this week was for CDD value of 56.4 with a normal spread of 5.9 CDDs. Kept my weighting scheme the same as the entire summer so far, 60% weighting on the 10-year normal, 40% weighting on our trend forecast on the table there right underneath my name. I've been looking for ways to improve my forecast. Haven't necessarily come up with a way to adjust my weighting scheme because, as we've seen so far, the 10-year normal is a pretty reliable metric in the summer, and I'm looking for ways to just even improve on that. Some things I'm looking into are the MJO analog that we have on that table there, because it's been directionally correct 100% of the time so far this summer. So looking, we'll see in the next couple of weeks if that formula changes, but as of right now, that's what I'm sticking with. It's worked well so far. I saw a lot of warmth in both models, not necessarily situated over the US and the CFS, some of it in the US and the EC. And the CPC is also showing some warmth. Again, as you had mentioned before, it's hard to tell how significant it'll be because it's only percentages of being above normal and not actual temperature values. But definitely some warmth there. There's warmth in the teleconnection signals. But I think that this forecast has a warm skew. But I didn't go, I'm glad my number wasn't absurdly high compared to some of the other values on the table, just because of how this week's verification went and showing that sometimes these cold verifications kind of slip in and catch us by surprise. So that was my ideas for this forecast.
And how many of you out there envisioned 10 days ago what's going on in the Carolinas, right? I mean, there's a lot of pretty big cities in there. It's a regional outbreak. But I mean, I don't know if anybody was watching what was going on yesterday. Now, what if you see that same kind of split? The video I do, the Atmospheric Avenger, shows August 24th, 2017 versus the European day 10, right? The troughs are in the same place. Now, that doesn't mean Harvey's coming, all right? What it does mean is Texas was uncommonly cool when Harvey and that's part of the reason that storm got stuck. There was a trough sitting in there that drove a lot of cool air deep in the south, which is, by the way, another interesting correlation, folks, is that when you get extremes one way or the other, whether the warmth is up way across the north or you get a lot of cold in the central part of the United States into Mexico, you look out in the tropics because there's usually higher than normal pressure over the continent. And what happens in the tropics is there's got to be a response to that, okay? So the response is convergence, right? When you have a lot of high pressure over the United States. So
Yeah.
So what I'm trying to say,
Carol,
hello?
Carol, come up here a second. Tell me.
So I think someone there is not on mute. If you could just go on mute, please.
I'm listening. I'm listening to David's conference on the computer.
Sorry about that.
That's all right. That's all right.
Okay.
So I think you see those temperatures over there. Wait till you get to 18Z, Dave. Take a look at the 18Z ones. So you'll see how cold they are. But you could see that happen across Texas in this period down the road. There we are. Is that, what time is that?
Oh, this is short term. What?
Yeah,
you're
right. But look
Okay.
at, you see how cold that was in there? You see how cold it gets in there during the day? You get a lot of rain and you get some kind of high pressure over the plains at the back of a trough. Then you're dealing with the Texas market coming offline as far as positive CDDs, right? And, you know, when you're looking at Texas versus the Dakotas, it could be nice and warm in the Dakotas, even up in the Northeast, but Texas can negate that. And that's something you have to consider, that, you know, the country could be warm as a whole, but the cool where it is can sort of negate it more so than what you would think. You could have the country true above normal, but major areas being, you know, 4, 5, 6 degrees below normal can really cause that problem. So I think the next battleground is Texas as far as where this is going.
Does anyone, I know we don't have too much time here. Sorry, I feel like I'm rushing, but does anyone have any questions for Joe based on whatever, his professional experience, the forecast, any of the above?
Just
that
a
we haven't-
comment,
Yeah, go ahead, Philip.
which is speaking about the CDD, it sounds like it's a similar issue that we had in the HDD season, especially during the beginning and the end of the HDD season, where, for example, I remember there was one verification where I think we all went warmer, so we had fewer HDDs, but then the cold happened to be in Chicago through New York, while the rest of the country was either near or slightly above average, and those below averages in the Chicago-New York corridor were enough to turn the HDD anomalies on the cold side, and I think we all busted.
Yeah, I think that brings up a question, Joe, that comes up a lot. At 16 to 20 days out, that far out and in that type of window, can you be as precise as you need to be in order to make a value add forecast? And how?
Well, I think the best you could do, what I do is, you know, I give it my best shot and then tell people what can go wrong, all right? And try to get them to weight it toward those possibilities, all right? No one knows tomorrow. You know, I'm one of these guys, and, you know, my spiritual beliefs that only God knows tomorrow. The rest of us are challenged to get the answer. And obviously, the further out you go, the harder it's going to be. But I do think that if we see, especially in the colder seasons, and even now, you see a strong Madden-Julian oscillation signal, you know, with high amplitude, you have to factor that in. And again, I think that tool is going to give, if you learn to use it and play with it, and it takes a while. I mean, I guess I've been looking at this since maybe the 2010. I really started getting into it, and I started figuring out how to play around with it. The other thing we have to worry about is that the correlations are changing somewhat. So I think we can sometimes use stronger, you know, if you have a lot of blocking coming back or something like that, you know, there's going to be a strong trough someplace around. You try to pinpoint where it's going to be in the winter season. But if you look at that, you can at least tilt the forecast and tell the guy, well, this model's saying this, but it's either going to be, 3, 4, maybe 5 degrees warmer. That's something you may have to look for, or colder. So, you know, when I do stuff, like I put the European on this morning and said, I would look for this to trend colder week 2. And, you know, when we come to the weeklies, you know, from week 3 on, it's just warm. And generally it's going to be warm, but it's not going to be warm the way that has it. There'll be pockets of cool in some places. And your job and my job is to try to pick out those areas, all right, where something can go wrong and give it your best shot as far as how wrong it can go. That's what I try to do.
Makes sense. Not easy either.
Well, fun. I mean, it was never meant to be easy.
Right. Otherwise, we wouldn't all be doing it, right?
Yeah, I mean, really. I mean, this is like, for me, this is like, you know, I wasn't a real good wrestler, but I get to wrestle every day with the weather. It's like every morning I wake up and God's left a gift under the tree for me to play with. So that's how you have to look at it. I'm whacked about this stuff, though. I take no days off. I know that it's like breathing to me.
Well, and you know, I know we're out of time, but Joe, I think it would be, you know, we try to do this once a week where we have these discussions. I know, I mean, it'd be great. Maybe we could have you back in the future again, because I'm sure there's a lot more questions. And I know one of the topics you just teased, and I think we could spend a whole session on it, is, you know, how do you account for the fact that the climate, you know, like you said, has shifted, and so you have to shift your analogs, or at least your thinking.
Oh yeah,
I think that's an interesting topic that it sounds like you've spent some time on.
Oh yeah, I listen. I don't care if it's the man in the moon throwing dust into the atmosphere or whatever. We as meteorologists have to deal with it.
Right.
All right. Whether it's natural, predominantly natural, like guys like me, us old guys think, a lot of us, or whatever. But we have to deal with it, and we have to try to get. And it's impossible for my brain, as limited as it is, to get a handle on the amount of extra energy being added to the atmosphere by the average increase of 1°C of the sea surface temperatures since 1985, right? I mean,
Right.
Think about that. If you go look at, I tell people all the time, look at saturation mixing ratios and what the correlation is with dew points. It's unbelievable. It takes a rise of 0.9 grams per kilogram to produce a 10-degree difference in correlation in the Arctic. You need 6.48 grams, 65 times as much, where it's 70 to 80 degrees, right? So can you imagine the amount of energy that's being poured in the air? Then what happens is it washes out all over the place, right? Eventually it gets all mixed up. And what you see is where the water vapors increase, maybe, 0.1, 0.2, there's a big jump in temperatures in the colder, drier areas. And then you look further down, there's not as much in spite of more water vapor being added into the air. These things are things that, it drives me crazy. I've talked to Dr. Mann about this every once in a while. And I want Penn State to take the lead in trying to get modeling. And I'm not saying I want the answers, give me the answers. I'm saying get modeling that can keep up with what's going on, because I don't believe it could keep up, but it gives you an opportunity, because if you take a tie with a model 90% of the time, but then you beat it 10% of the time, if you beat it 30 days out of 363 days, all right, imagine the difference that can make to someone. So that's how you look at it.
Excellent. Yeah. I think that's probably a great place to leave this. Joe, I think this has really been awesome having you here, and providing your expertise on the subseasonal. And I know it's just the tip of the iceberg. So again, we're definitely going to invite you back. Hopefully we can have you back again in the future. So thank you.
Oh yeah.
Yeah.
I appreciate you. I appreciate you giving me the chance to speak with everyone. I sometimes, my mother calls me up and she says, "Why do so many people hate you?" I was like, I'm basically a happy guy. And, I'm one of these guys that go, something? I realize at the age of 64, I can be wrong and be quite wrong. And the object is to pursue as hard as you can, as objectively as you can, and then see what kind of benefit you can give the people around you. That's what I think weather's about to me now. So anyway, God bless you all. I'm going to take off. I have to get back to State College.
All right. Safe travels. Thank you, Joe.
All right. See you guys
Thank you,
later.
everyone.
Thanks.
Bye-bye.